Ji Bismillahirrahmanirrahim. Today we are going to calculate the weight of steel in a beam, and I'm going to make a spreadsheet for that. आप लोग एक spreadsheet बना सकते हैं. We have this beam here, and this is a very easy beam. You can see that there are two number 4 bars and two number 4 bars here, but let me make a spreadsheet in which you can easily calculate the number of the weight of the steel according to any number of steel bars placed at the top and at the bottom, and the stirrups as well. You just need to input the number of bars, the diameter of bars, and the length of the beam, and all the weight of the beams will be calculated for you. Also going to teach you how you can calculate that. So let's make a spreadsheet. First of all, I'm going to give a heading here. Steel calculation of beams. Let me write RCC beams here, and I'm going to increase the size a little bit so that it's easily visible. Now I'm going to input some details from the user. Enter number of bars in top, enter the number of top bars. So here let me merge this one. We are going to take the input values from the user, and he has to enter the number of top bars, how many bars are there. Enter the size of top bars. In this you can say tutorial, I'm going to make this of uniform size. मैं एक size की सिर्फ bars के लिए बना रहा हूँ. You can make that for customized bars as well. You can have for two sizes of bars as well, according to the same procedure. So this will be in, let's say, numbers. Enter the number of top bars. Let's say I'm going to enter 2 bars here according to this diagram, and the size of the top bars is I'm going to enter number 4. So I'm going to copy that, I'm going to place here. So in front of, instead of top bars, I'm now going to write bottom bars. Enter the size of bottom bars here. I'm going to increase the length here. So now you know that density is equal to mass per unit volume. This is a very basic formula. You know that आप लोग ये पढ़ के आए हुए हैं. Everybody who is from science background, he knows that. So if you want to calculate mass from here, you just need to multiply the density with the volume. Fine, we know that. I'm going to input the length of the beam as well. Now the units I'm going to make meters. Units should be consistent here. We need to perform this conversion. This I'm going to use the formulas. This divided by 8. This is the answer I'm going to get in inches. And once this is in inches, now I am going to convert this in meters. Multiply by 0.0254. This is the factor, meters. If you don't know the factor, you can just Google that. 1 inch is equal to how much meters. So this calculation will be automatic. When you're going to enter 8 here, this is going to automatically convert that. So this is the benefit of a spreadsheet. When you change the top sizes, it is going to change the sizes in meters. So the length of beam, let's say we are going to enter in feet first, let's say 6 feet, and it is going to convert this in meters. 3.281 is the factor in meters. Automatically it will be calculated in meters. Now according to this, we all know that the density of steel is 7850 kgs per meter cube, but I am going to let user enter the value the density of steel. So the units I'm going to use is, it's up to you, pounds per cubic feet, or you can say the kilograms per meter cube. Since I'm going to use the SI units, I'm going to use kg per meter cube. So I'm going to use this. I'm going to subscript that, superscript of course, not subscript. So I'm going to enter here. All these yellow colors cells are the input values, 7850 kg per meter cube. Now comes the solution. First of all, I'm going to calculate the area, cross-sectional area of the bars, the top bars and bottom bars, and then I'm going to calculate the volume of these bars. Then I'm going to calculate the weight or the mass of these bars. So I'm going to write here area of top bars is equal to, now you know that area of a circle is pi r square. Pi value returns 3.14 multiply by, now radius, this is the diameter, divided by 2 gives you the radius, pi r square. So I'm going to put a square here, pi r square. This is the area of one bar. So if you have to find the area of two bars or area of number of bars provided, multiply by this cell. This is the number of top bars, it will be multiplied with the number of bars. I'm going to write here meter square, also going to make that to superscript. So if we see pi r square into number of bars, so this is the total amount of area of these two bars provided. Similarly, if I want to find the volume of these bars, so I'm going to write here volume of these bars, volume of top bars is equal to this area multiplied by the length, which is 1.8 meters, and you get the volume of the bar, top bars. This is for the two bars here. So same thing I'm going to repeat for the bottom bars. Area of, I'm going to write here bottom bars, enter the size of top bars we provided here, enter the size of bottom bars, we did not convert this one, so I'm going to copy this and paste here. Now it is fine. So enter the number of bottom bars, there are two bars, and the size of the bars is this, fine. These two are same, so because in this example we are having the same values. At the end of the example I'm going to show you that if you change the values, how it is going to perform the calculation for you automatically. So volume of top bars, control C and control V. Now it is asking me for the length, I'm going to use this cell, and it is providing with the volume. I'm going to calculate the mass now. Mass of top bars, this is equal to volume of top bars multiplied time with the density. So you get the answer in kilograms. Mass of bottom bars here, I'm going to drag this and I'm going to use this cell and I'm going to use this volume of bottom bars, which is, I did not change this volume of bottom bars. Now I'm going to use this cell, enter, and we get the same amount in kg. Now I'm going to total that, total amount of steel, let me say longitudinal steel, because there are stirrups as well. So we are going to just sum these two columns, this plus this, and this is in kilograms. If you want to just round them, this is the shortcut key, 3.64. let me use 3 digits here. So I'm going to center align that. So this is the amount of steel required for a length of 6 feet. If you are going to change that to 1 feet, you can easily see that how much is the amount of steel that is changing. 3.281, this is equal to 1 meter. You can see here the amount of steel total required is around, you can say 4 kilograms. You can also cross check that, आप इसको देख भी सकते हैं कि ये सही आ रहा है या नहीं आ रहा. तो 6 feet is going to give us around 7.2 kilograms. Now the same thing I'm going to do for the stirrups. Enter the you can say size of stirrups. This is the, I'm going to insert a bar here. I'm going to give a heading of stirrups and I'm going to bold that here as well. Enter the size of stirrups, and the spacing of stirrups are also required. Here according to this picture, this is number 3 at 8 inches. So I'm going to use the same thing, Control C, Control V, 3 by 8, and this is in meters. I'm going to indent them as well. Spacing of stirrups provided here is 8 inches. So I'm going to write here inches and going to convert that to meters. This multiplied by 0.0254 meters. Fine. So now I have to find the area of the stirrups, which is, this formula is same, area of stirrups. I'm going to do this for the 1 bar only. So this is pi into r square. What is the radius here? I'm going to use this cell, pi r square into the number of stirrups. Here the number of stirrups are not yet known. So how to find the number of stirrups? The length of the beam is 6 feet and the spacing given is 8 inches. So the number of stirrups you can calculate easily. Note that this is This practice is for the uniformly spaced stirrups. If there are beams having more closed stirrups near the joints and lesser closed stirrups at the center, then you can change the sheet accordingly. But this is for the uniform spacing of the stirrups, so that you can get an idea how to make a spreadsheet. Number of stirrups is equal to, I'm going to convert this 6 feet into inches, which is 72. Let us convert them into meters, because we are going to perform every calculation in meters. So we have the length in feet, we already have the length in meters, so just going to select this cell. Number of stirrups divided by the spacing, which is 0.2, you get 9 spaces. I'm going to round that up. So yeah, number of bars are 1 greater than the number of spaces, so I'm going to add plus 1 here, so to get number of stirrups. Why number of bars are 1 greater than the number of spaces? Because if these are 2 bars, they are having 1 space in between them. So that is why if we are having 3 bars, they are going to have 2 spaces in between them. So that is why the number of bars are always 1 greater than the number of stirrups. So now if you change this size of stirrups from 4, the calculations changes. Now we have the number of stirrups. We are interested in volume of stirrups. I can skip this step as well, but if you want to do that, then it's fine. This is equal to area of stirrup multiplied times the length of the stirrup. Now this is the length, this length, and this length is obtained either from the bar bending schedule, or we can calculate that from AutoCAD as well. So if we have to find this length starting from here, 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 here and here, so then we can enter the length of the stirrups, length of the stirrup here. I think we need to input the length of the stirrup. So let us say this is 38 inches. Let us say this is 38 inches. I'm using a rough value, not a, you can say, actual value. I'm just going to add this 9 by 9 by 9 by 9. This is not actually 9, so from this side this might be 8. 4 8 is 32, 33, 34, 35, 36. So I have not added the rounding of this bar, so that's why I've added 2 inches for that, and we can have 38 inches. Anyways, whatever the length you get from the bar bending schedule, you can use here. You can input the length here. Now for the volume of the stirrups, we can find easily by using the same method. Volume of stirrups is equal to area of stirrups multiplied with the length of the stirrup multiplied with the number of stirrups. We get the answer in meter cube. I'm going to copy that, and now if you want to calculate the mass of stirrups, then you just need to multiply the density with the volume. So I'm going to write here mass of stirrups is equal to formula volume multiplied times the density of steel, which is 7850. I get the answer in kilograms. I'm going to copy that and paste here. I'm going to round off these answers to, let's say, 2 decimal places. That's it. This is the mass of stirrups which we have obtained, and you can even make this bold that this is the amount of steel which you need to purchase now for this beam. So it was very easy. You can change the amount of stirrups, the amount of size and the spacing, and you can have the total amount of steel. Now let's say if we are having stirrups of number 4, you can see the amount doubles automatically. Oh, not actually double, but of course it increases according to the size, and because the area increases, the uh, volume increases and the weight, or you can say mass, increases. Now if you change the spacing of the stirrup here from 8 inch to, let's say, 10 inch, the number of stirrups decreases and the mass of stirrup is 7.87. Now it also changes. If you want to change that to 5 inches, you can see the number of stirrups increase 15. So similarly the mass of stirrups also increase. I'm going to change back that to 8 inches. You can see the 9.6 kilograms of steel is required. So in this way you can make a very easy spreadsheet of any steel calculation, and in order to make that more user friendly, you can even make this beam here and point out the number of top bars directly by making arrows, and you can make that in more graphical user interface for the users to use that. So I'm going to just save this file, and that's it for today. Thank you. Allah Hafiz.